I don't usually give talks, but I figured this would be a good opportunity to take advantage. My name's Janum Trivedi. I am a designer, prototyper, and engineer. The order kind of changes over time. And I'm really excited to be here. Thank you to Slug and Lyft for hosting this as well. To give you a little bit of background on myself, I work on a lot of kind of random UI projects. I like poking around at like the boundaries of what we can do in digital software. And it's kind of like my hobby and my career. And I have a quick talk to tell you about how I made something over the last couple months that I think has been kind of fun. Anyway, without further ado, this is hardware to software. So I was getting coffee with a friend in San Francisco a couple months ago, and he's kind of into like wristwatches. This is not like an interest that I have. And he asked if I was familiar with something called the Guilloché pattern. I had no idea what he even said to me, but it turns out Guilloché is a 17th century like watchmaking technique where these like old craftsmen would like engrave these really intricate patterns into, you know, like pottery and jewelry and all sorts of things, including this watch. And this is a watch by the Finnish watchmaker named Lane. And I took one look at this and it really kind of stuck in my brain. And I was really curious, like, how could you take something so physical and tactile that responds to lighting in this way and bring this into the digital world? You know, I think it's really wild, right? You look at the center of it and kind of these waves emerge from the center moving outward, but then also kind of as you travel across the watch dial itself, you see these waves. And just in like a really cosmic way, I don't know if anyone speaks Finnish, but it turns out lane is actually Finnish for wave, which I just think is like ridiculous. I have one other photo of a Guilloché watch face, and there's a whole ton of these examples out there. But I want to call attention to like how these watch faces look really different at different angles. How you see these shadows and highlights and kind of this like glimmer of the enamel at different angles. And I was really interested in recreating this because I like making software that kind of feels like natural and alive, right? So I couldn't not do this. And I had three goals that I wanted to focus on here. And the first is I wanted the watch effect, this dial effect, to have the same kind of visual fidelity. I wanted it to really match that same kind of pattern of the original engraving. The second is I wanted it to have dynamic lighting, and that means making this thing three-dimensional. I don't want to just kind of fake it and move around shadows or something like that. Like I want it to feel realistic. And if it's going to feel realistic, it probably needs to respond to motion. So I want to be able to move my phone around and really have it feel like, you know, I'm looking at a Guilloché pattern. It's kind of tough. I didn't really know where to start. I didn't really know where to model it, both in terms of how the pattern actually works, but I also wasn't even sure kind of like, you know, it wasn't clear to me what technology to use. So let's go through a couple of candidates. Yay! We're all expecting me to talk about Swift UI. I'm not. This is the wrong tool for the job. Does a lot of great things, but Swift UI, and I would put UIKit in this category as well, is a two-dimensional user interface framework. Swift UI does have some nice, you know, visual effect support, this and that, but fundamentally, you know, this is for rectangles, and I don't see any rectangles in this Guilloché effect. Our other option is SceneKit, which is Apple's like somehow still existent but not quite deprecated 3D framework. It's a really strange library, but this essentially lets us render three-dimensional objects like these cylinders or squares or whatever, and set up lights and cameras and reflections. So that would be really nice if we could take advantage of that. But the problem is, this Guilloché pattern, it's very fluid in these waves, and I don't really know how to translate that into a bunch of polygons and triangles. I think my other option with SceneKit is I could probably model something in like Blender and then kind of bake that and run that on the app, but you know, I want it to be real time. I want to be able to modify this effect whenever I want. So we come to metal, which is, you know, if you stop here, you've probably done something wrong, but I think it's worth it for this. So let's talk about like why metal and metal shaders is like appropriate here. And if anyone's unfamiliar, Metal is Apple's shading language, so it's kind of like GLSL or WebGL. And the fundamental idea of fragment shaders is that every pixel on every single frame is asking a very simple question, which is, what color should I be, right? Traditional UI frameworks, we say, hey, put a square at this position. Instead, a shader is going to say, I'm a pixel at coordinate 20, 40, and I'm going to be this shade of blue or something. You get a ton of control. You can do really just about anything. You get a lot of control, and it's extremely painful. But you can do like literally anything. And I want to give you a couple motivating examples of what's possible in like a simple metal shader before we kind of get back to the watch. So this is like a very simple shader, right? We're seeing this kind of, this little wave effect. And this is not like an affine transform. It's nothing like that. And it turns out you can actually write this effect in like 5 lines of metal code. I mean, you could make this a one-liner if you really cared about it. This is a simple displacement effect, which is a Swift UI modifier that came out a couple years ago. So that's like a really simple example of how we can move pixels to our will. We do slightly more interesting things. So this is a little prototype that I made of like the dynamic island animation, the dismissal thing. So this is like my own little project here. And this is also a displacement effect shader to create this kind of mesh transform and warp. I think it's quite neat. But you can do things that are fundamentally not two-dimensional at all. So you can do things like this. So this is not a video. What's playing here is actually a procedurally generated terrain, all just in a metal shader. So in the keynote, it's a video, but if you talk to me after, I can show you these different demos, and I can literally put my finger on glass and kind of scrub around as if it were like a video game. So there's no assets being used here. It is like all just one metal shader. So that's what's possible. This is usually the part where people are curious about like learning shaders, so this is the site that you want to visit. Please check it out. The book of shaders is incredible. It is interactive. So our plan here is we're going to try to model this Guilloché watch effect by creating a whole 3-dimensional scene in a fragment shader. And we're going to use a technique called ray marching. If people have heard of like ray tracing in video games, this is kind of like a cousin of that technique. And it lets us, create objects like circles and cubes and really whatever we want, and render them using mathematical representations of them, which we don't really need to care too much about what that means right now. But the point is we define these shapes not in terms of vertices, polygons, and triangles. But because this is all shader-based, we need to kind of from scratch implement our own lighting, cameras, all of that kind of stuff. I was able to kind of break down how ray marching works in exactly 37 words, just because I think it's kind of interesting. So the idea is you simulate a camera, and this camera has some particular position. And the camera is going to shoot a ray to every single pixel. And kind of along that direction, it's going to keep marching that ray until it hits some object. And if it doesn't hit some object in some amount of distance, we say, okay, we didn't hit an object, there's no color. And you do that on every single pixel, and this runs on the GPU, so it's GPU accelerated, which is why something like this is even possible at all. Finally, when we do hit that object, we kind of calculate the intensity of the lighting, and we return that multiplied by the color of whatever material that we hit, which we're all simulating. So you do a ton of work, and then you get something like this, which is incredible. Thank you. Yeah, this talk's a huge waste of your time. So this is actually a ray marched scene in metal using SwiftUI's layer effect. And here I'm just over time rotating it, right? But what do we notice? We have some shadows, we have some highlights. To me, if I can get this, if I can get something like this running on screen, you can kind of create anything. And so we can color it. Okay. Now, the nice thing about ray marching and SDFs, which are these functions that we represent these shapes with, is that we're actually able to like displace the object to give it grooves or valleys or things like that, right? So if you think about that original Guilloché watch effect, right, the metal is being engraved. And so we can really simply actually engrave that same effect. So what we're looking at here is the face of the cylinder is turned to the camera, and based on the radial distance, we're just doing some simple engraving. Okay. But it still looks nothing like this watch. And I was really trying to figure out, okay, now that I have this infrastructure set up, that I have this 3D cylinder, I can carve into it, but what math and pattern do I use to carve into it? So I kind of went down some rabbit holes, and I found this video from, like, you know, the Tiffany jewelry company. And this is a video of someone actually using the Rose engine lathe to engrave these really, really tiny Guilloché effects. And I want to point two things out here. The first is that this effect is not starting from the center and moving out. It's starting radially at the circumference. And the second is they do one ring, and then they're adjusting something. And if you look really closely, this dial is bumping in and out ever so slightly, which is what creates that depth. And at the end, you end up with this. So, okay, so I have some hints now, but I needed, like, something to get me over. I needed, like, one more hint. So I found this woodworker named, like, Bill Ohms, who wrote this paper called Offset Sine Guilloché Math, which we're going to read the whole thing right now, and then I'm going to quiz you. We're gonna skip a lot of this stuff, but I want to zoom into this image right here, which is like the entire key to this effect, and it like blew my mind. So what we're looking at here is this is essentially saying that all of these rings are just a sine wave that's engraved, kind of moving radially outside the dial. So you use one sine wave to do your engravings to go in and out, and then what did that watchmaker do? He clicked something. So he actually shifted that sine wave just a little bit when he moved to the second ring, and then a little bit more for the third ring, and changed the phase shift until you get to the center. And it turns out this is how you create this 3D valley-like structure. It's just offset sine waves. So with that, I want to give a little bit of a demo of where I ended up. So 1 second. So apologies if this is like a little bit dull, but you can see it in person after. But I have my phone here, and I'm moving it around, and this is actually the Guilloché effect happening in real time, all in a shader. If I turn the phone to like fully face me, the light source is like right here, so we'll see that we only see light at the top, and I can even kind of move it around, right? But what's neat is because we're doing this all in metal and we're not using any pre-baked 3D models, I can actually parameterize like the whole thing and just like change everything about it. So I can change the frequency of the sine waves of the engravings, right, to make it like super dense and change it, right? I can even reduce it to none, and I actually get this like, you know, vinyl record effect. Well, let's turn that frequency up. Okay, cool. I can change the amplitude of those sine waves and how they get engraved. I can zoom the pattern in and out. Change things like the cut slope. And I can change like the material of the metal too, which is kind of fun. And again, this is something that you like, I really want to show y'all all y'all in person. It's quite neat to move this around and try all the different you know, variations of it, and you can kind of make your own. But yeah, I think this is like a really interesting process of taking something that inspired me in like the physical world and kind of like figuring out, you know, what steps do you need to take, like what ridiculous steps might you need to take if you want to like recreate something that like feels so tactile, right? I did have one more thing, which I'm going to actually let you down about. The one more thing is, you know, the whole talk is about building a watch face, and I'm showing you this on an iPhone, right? Yeah, fair enough. So it turns out you can't actually create third-party watch faces on the Apple Watch, which is too bad. But I was actually able to get this running on an Apple Watch as well. You can't run metal on an Apple Watch, but oh, sorry, 1 second. Okay, all right, we're back. You can't run metal on an Apple Watch, but you can write GLSL, and there's some tricks to get that running. Xcode was not playing nice today, so I can't unfortunately show you that. But you can run this on an Apple Watch at frame rate. Anyway, yeah, thanks so much, and I'm happy to answer any questions if people have any.
That's really cool. How are you displaying the metal view within Swift UI? Can you talk about the implementation?
Definitely, yeah. Also, when I have a little bit more time, I'm probably going to open source this whole project. I didn't want to show you like random code snippets that wouldn't make any sense in this quick talk. But in terms of the implementation here, so there's effectively just like, a Z stack with a color, and then it's just calling the layer effect modifier, which loads up a metal shader from a metal file. Then there's like I'm using core motion and a display link to on every frame update the Swift UI shader with those new parameters. Something I will say, that Apple I hope does fix is that running metal shaders this way is actually pretty not performant right now, but not because of metal or the GPU. It's actually because of like a issue with Swift UI, which on every single frame it's like invalidating this view hierarchy. So the CPU usage is like really crazy. So if I were to do this in production, I would actually use like a MTK metal view or whatever the UI equivalent is. It's like more annoying to set up, but like super performant. All right, thank you.